Hello everyone, welcome to this YouTube channel. Today we're going to talk about electricity. Have you ever wondered how the light bulb in your house comes to life with just a flick of a switch? When we walk around our neighborhood, we hardly notice the integrated electrical infrastructure surrounding us, such as poles, wires, and substations, because everything just works. The lights turn on, a device is charged, and life flows seamlessly. But have you ever stopped to think about how electricity gets to you? Behind that light bulb is an incredible journey, a journey of electricity traveling through the vast networks of wires, equipments, and systems, all starting from a generator. Today, I'll take you on that journey, showing how electricity is generated and delivered right to your home. In this video, we'll explore the basic electrical network. I will be taking Australian electrical network as an example because Australia uses 50 Hz and 230 volt. Different places around the world uses different frequency and voltage. So we'll be taking Australia as an example. The grid has three major components: generation, where the electricity is generated; transmission, where the electricity generated in the generation is transmitted; and the distribution network. The distribution network is the network that you see around your neighborhood and that actually connects to your house. While this video will simplify the concept for understanding purposes, keep in mind that in the real world there are variation in voltages, configurations, and setups. But by the end, you'll have a solid understanding of how electrical network works. Let's start at the beginning. Generation. Electricity is created in generator, which converts energy from a variety of sources into electricity. These sources can be renewable energy sources such as solar, hydro, and wind. In case of solar panel works by converting sunlight into electricity through photovoltaic effect. They are made of solar cells, typically using silicon, which absorbs sunlight and excite electrons, creating an electric current. This current is direct current, which is then converted into alternating current by using inverter, so it can be used to feed into the grid. Hydropower, on the other hand, turns the force of flowing water into electricity. By releasing water from a dam, it spins turbines that generate power. It's a clean, renewable energy source that taps into natural water cycle. Similarly, we have non-renewable sources of energy such as nuclear and coals. Nuclear energy is produced by splitting atoms in a process called fission, which releases a tremendous amount of energy which is used to generate electricity. It's a powerful and efficient energy source, but comes with challenges like radioactive waste and the potential for accidents. Coal, on the other hand, is a fossil fuel that is burned to produce electricity. It's abundant and has been a primary source of energy for decades, but it releases significant amount of carbon dioxide and other pollutant, contributing to climate change and air pollution. Both sources are non-renewable, meaning that they will eventually run out and have environmental impact as well. The generation is done in lower voltages because for lower voltages, the insulation required is low. If we use higher voltages for generation, the weight of insulation would be higher and efficiency of the generation would decrease. So once generated, the electricity is stepped up to higher voltages using transformer located at generating substation and sent through long transmission line. Now, let's dive into why we need to step up the voltage. The power before and after the transformer that step up the generation voltage is equal. For example, if you are sending 1 megawatt of power to the transformer, it will still be 1 megawatt before the transformer and after the transformer. So the only thing that changes is the voltage, and the formula for power is voltage multiplied by current. By stepping up the voltage, we increase the voltage So to maintain the same power, we need less current. The formula for power loss is square of the current into resistance of the transmission line, meaning power loss is proportional to the square of the current and the resistance of the transmission line. Since the current has decreased and the resistance of the transmission line is constant because we are using the same material and we are not changing the property of the material, the power loss decreases as we decrease the current. Therefore, as we step up the voltage, the power loss in the transmission line decreases. So that's why we step up the voltage before we transmit it through really long transmission line. Once electricity travels through high voltage transmission network, it arrives at bulk supply power point. From here, it's divided into sub-transmission lines leading to distribution substations, also known as zone substation, and large-scale consumers such as factories that require significant power. In summary, the transmission line connects to multiple bulk supply points, and each bulk supply point connects to multiple zone substation and large-scale consumers. At distribution substation or zone substation, the high voltage is stepped down to more manageable level using transformer. The voltage is then distributed through multiple feeder, typically at 11 kV, on our streets. The three wires on top of the pole are generally 11 kV, while the four wires running below are usually 400 volt. The 11 kV high voltage at the top of the pole is connected to the 400 volt lower voltage at the bottom of the pole using distribution transformer. The low voltage include neutral wire along with three-phase wires. The arrangement of the coil inside the transformer step down the voltage from 11,000 volt to 400 volt. If you measure the voltage between the phase, it will be 400 volt. However, if you measure the voltage between any phase and the neutral, it will be 400 by root 3, which is equal to 230 volts. When connecting wires to your house, since houses are generally single phase, one neutral and one phase wires are connected to the main switchboard. Different houses are connected to different phases to balance out the load on each phase of the transformer coil, and that's how the power generated in the power plant gets to your home. Thank you for watching. If you found this interesting, don't forget to like, share, and subscribe.